Awesome. I guess the recording started. Well, first of all, good evening, everyone, and thank you for coming today. This is the first workshop for the UW Athletics Data Science Contest, and today what we will be going over is web scraping. We'll be going over some of the methods and some background about it, some needed libraries and software that you need to install. We will be walking over that. So I guess we have yeah, it's 6:02. We will get started right now. It will be a brief introduction in the beginning. So for those who join us a little bit later, they'll be able to catch up. So without any further ado, let's get started. So the outline for today's session will be, first we'll be doing a brief introduction on web scraping. Why is it necessary? Why is it important for our project and in general? And then we'll be walking over some of the installation required for like software and libraries that are needed for this task. And then we'll be covering two different methods for web scraping. And the reason why we'll be doing two methods and not just one is that when you go about the project and you get started with it, encounter some websites that require a method and then others would not work with that particular method, you would need another one. So we'll make sure that we teach you all the needed methods that you encounter during this project. So we'll be going over Selenium, and that's one method, one library in Python that is used for web automation and scraping. And the other is a combination of a library called request and beautiful soup. And then if we have some time at the end of the session, we'll also go over how to acquire the API for the census data. And that's a straightforward process. I'll be showing you how you can register for a key, and you should get a key attached to your .edu account email within a day. So I'll be showing you how to do that. And last, we'll have questions all along the presentation. So if you have any questions during the presentation, please unmute yourself and just ask. And if not, if you want to wait until the end, you can do that as well. Feel free. It's an interactive workshop. So let's get started. First on web scraping, the importance of it, and then why we're using it in this project. So of course, as you all know, web scraping means basically fetching or getting data from the internet, online sources, web pages, and so on. It allows to gather data that's available through APIs or other sources. So whether you go on a university's website to get a roster or any source of data that you can find online, the techniques we'll be teaching you in this workshop, you can apply either to this project or any other particular application you're interested in. And then there's some important ethical considerations. So I'll be showing you something called, I don't know if you're all familiar with it, it's called robots.txt. And that's basically a command you put after any website. When you go like google.com/robots.txt, it would tell you whether you're allowed to get certain data from this website or not. And this is important for us. We don't want to go on and get some data from a website that has like copyright or like does not allow scraping from the particular website. We'll be showing you that as well. And finally, the particular libraries we'll be using, as we mentioned, are Selenium and a combination of request and beautiful soup. And those are two different methods. The main difference between them is that request and beautiful soup can be used for almost all HTML/CSS pages, whereas Selenium is like when you have a more complex JavaScript page. We'll show you the particulars of that as well. So want to get started with some importance like housekeeping at the beginning. So I'm sure like a lot of you probably already have Python installed and Jupyter Notebook. For those who don't, this is just a brief outline showing you how to do that. So basically, to install Python, you do that, of course, from the official website, python.org. And you make sure that you install the version specific to your machine, to your operation system as well. So if you're Windows, say it's 64-bit, you make sure you download the version that is compatible with your device. And for the Mac users, of course, that's a method called Homebrew. To be honest, I'm not very familiar with Mac myself. I never use Mac, but if you guys find this particular command not working for you, reach out and I can help you with that too. But I'm sure the majority of you have Python, but if you don't, this is how you generally go about installing it. And then for Jupyter Notebook, again, a lot of you might already have it. But for those who don't, well, you can have it one of two ways, either as part of a package in Anaconda. If you already have Anaconda software, you'll have Jupyter Notebook within it. And another way to do it is through your terminal or command prompt, where you just write pip install notebook, and it should install Jupyter Notebook for you. This is the method I prefer because, well, for me personally, I think launching Anaconda takes a very long time, and then whereas if I run Jupyter Notebook separately from the command line, it generally goes a lot faster, but they both work just the same. And this is just for installing the main software we're going to be using Python and Jupyter. Of course, there's so many different ways to go about web scraping and use different software or different programming languages like C++ or like maybe Java or anything like that. But I think Python is the most popular, so that makes a lot of resources available for it and makes the whole task in general easier. But that's just my opinion, and it worked for me in this project, so I think you guys will find many applications for it too. Next, another important tool that would be needing during this workshop is something called Chrome driver. And that's basically a browser that allows automation through Python. We'll be using, one of the libraries we'll be using is called Selenium. And what that library does is that the way you go and open a web browser and then you go to a certain web page, maybe you find a table of roster of players and you want to copy it. You do that manually. And what this does is allows you to automate this whole process. It opens the browser on its own and then copies whatever you want to find on that page. And in order for you to do that, Chrome or Explorer or any other browser that you currently have on your machine has certain restrictions on automating tasks on it. And what this browser does is basically a browser that looks exactly like Google Chrome. However, it allows automation on it. And there are different drivers. There are Chrome driver, there's Internet Explorer driver, there's Firefox driver. But Chrome driver is, of course, it's the most popular one, and that makes it, of course, have many fewer restrictions. And for me, it works a lot faster than other web browser drivers I tried. But again, it's one of the tools that you have flexibility with. You can try maybe Firefox driver if you're more comfortable with that, or any other browser that you're more comfortable. Almost like, I would say like almost all the popular browsers have their own drivers that you can install from the same link here. Can you drop the link to chat? Of course. Let me add that to chat. I'm sharing the link with you all right now in the chat. There you go. And just like with installing Python and any other software, there are particular versions for different operation systems and different machine settings. So make sure you download the one that's compatible with yours. While you all install this, I'll be going over some of the libraries. We're not going to get started with the workshop until we finish all the slides. We have a few more, so we have time to install this while I'm going over the remaining slides. And then the libraries we'll be needing during this workshop, first of all, is Selenium, which is the one I was talking about. It's mainly used for web automation applications. And then, of course, part of automation, what we're going to be doing here is the scraping. So it's going to be part of the second method we'll be doing for scraping, because some websites block our beautiful soup, or like not blocked. You cannot access the variables or the tables that we have data we're interested in through HTML. So it need it to be stored more complex JavaScript, obviously like variables. So we use Selenium for that particular case. And I'll show you how to install it, but generally is that you just run pip install Selenium, this command down here if you see it. So if you run this in Python, and then your Python would basically install the library for you. It would be important when you start the workshop. The other library you will need, I think this comes installed, probably all of you have it installed already. It's request, which is allows you to send HTTP requests, so access internet URLs. And of course, we're using it in this case alongside with Beautiful Soup to scrape HTML data. And again, install it the same way, you just run pip install requests. And depending on the version of Python you're running, so some require different additional inputs. Maybe you have to put like -m or something like that, depending on the server you're running on. But generally, pip install requests should work on almost like, I'd say 90% work with 90% of users. Next, we have Beautiful Soup, and again, I think many of you might be familiar with it. If not, don't worry about any of those libraries. We'll be going over each and how to use each. If you're not familiar with them, it's not a big deal, but we just want to make sure that you know what they're using for and how to install them. So to install this one, you just run in Python still, you run the command pip install Beautiful Soup for. And what this does is basically, we use it for web scraping to pull the data out of HTML and XML files. So we can create some called parse tree and make it easier to like search through the HTML documents. And finally, This one, I'm certain everyone who knows Python knows this one, pandas, which is, well, we'll be using it. Well, it's a popular open source data analysis and data manipulation library. So that means it allows us to um, analyze and manipulate the data we'll be scraping. So we will need it to store the data and then save it in files that we'll be accessing later. So that's again, make sure you have this one installed with pip install pandas. Before we get started with the workshop, anyone had any questions so far? Okay, if no questions, I will get started with the demo. So what are we interested in? What we're trying to do is basically, if you look for particular, why are we interested in scraping, right? The reason for that is that we want to go on, let's say, for example, let's go on Google first. You want to get the players rosters for all the universities we're interested in and getting the data from, right? So let's start with, say, with UCLA football roster. And if you Google that, I'll give you a link to the university's websites, or like the athletics department website for the university that has the roster for the team. And now you might ask, like, why are we going to every individual university and we don't go just to ESPN, which has the roster for all the players? And the reason for that is that we're interested in looking at the trends over time. So in ESPN, you'll only find the most recent roster updated on the pages for each team. Whereas if you go to individual universities, you'll be able to look at the rosters for all the year. So this is the page for ESPN, which has only the roster for the current year. Whereas if you go to the individual university's website, you'll find an option here to look at a particular year's roster, right? Of course, different universities start from different years, but I found the most consistent year that most start from is 2010. And that's why we did the analysis we looked at last time, starting the year 2010. So this is our target, right? This is the data that you see right here is the data we're trying to extract and compile, right? It has everything we're looking for. It has the player's name, the position, height, weight, the academic year, and hometowns and high school. And you'll notice that different universities will have slightly different formats. They'll have different information added or moved from those columns. But in general, you'll find, like, if you think about any other university, look at UW-Madison football roster. You'll find a lot of similarities, which makes this task automation like slightly like not very straightforward, but easier than you might think, because there are a lot of similarities in the athletics websites for most universities. Let me. At first, you might look at this and be like, "This is completely different," but well, you have the option to view it similar in a similar way that we just saw for UCLA, right? So if you look at maybe grids, yeah, in general, the same information is present, but the formatting is different for this one. We'll be going over how to navigate through different formattings and how to automate the task as much as possible. So let's get started with this particular table, right? What we want to be able to is, I don't know if you're all familiar with inspecting element on web pages, but each element you see on this page has something called the class ID, right? So, for example, this button right here, the options that you click here, and this table in general should have a class ID. But what we'll be trying to do with Python is that we're gonna tell it that, hey, what we want you to do is, first, I want you to look for the button that selects the different years, right? So if I go from, like, let's say 2022, and I click go, I want to be able to navigate through all the years, right? I want the automation to do this. I want the Python to do this. It's like, hey, go through all the years I'm interested in. And when I started doing this, I noticed that, well, if you look at the link, the only thing changing is that we're adding a year to the URL at the top, right? If I change this from 2022 to 2021, it takes me to 2021 roster, right? So of course that immediately gives you an idea of how we can go about navigating through the different years rosters is that we're basically gonna create a loop to go through all the years, and then to get the table from each, we want to run a web scraping library, either Selenium or BIOS Soup, that allows us to look for this particular element in the table and get the information that's in it. So if you want to find the name of this class, or like they call it a class, which is the container for the data of the table in this case, we'd basically go and click on this, right click on this page and do inspect element or inspect. And then if you see this button right here at top, that says select an element in the page to inspect it. If I click in it, I click on it, sorry, and then I look for the table and I highlight it, I'll be able to find, well, in this case, I go to individual rows. You'll find that they all have this tag code, which is TR, right? Which is basically represent a row of data. And then there's also one for the table. I have a class called, well, this name for the table, right? So what I'll be doing is, my target is going to be is that I'm going to tell Python that, hey, I want you to look for a class that has this name and this pages. And then when you find the name, when you find this table, which is, well, we're going to locate it through the name of this class, I want you to go through all the tags under it that have, well, the name row in this case, or the role row, right? You can see they're trying, like, they give it different names for the rows, like the classes are called odd or even, whether it's odd or even. You'll find very interesting formattings for the different universities' websites. But once you see the general trend, you'll realize that automation is not that difficult. Once you do it for one, it'll be easier to do it for all the universities. For UW Madison, you find a little bit difference, a significant difference actually, as compared to what we just saw. If I do inspect element in this page instead, you'll find that we're not going to have the same names necessarily for the classes, but you'll see that it's very similar in terms of the way it's the outline of the structure of the page, right? You see, again, I'm going to have a class for the table. Underneath it, I'll see, like here, I can see the players, a column, and then this is the overall roster for the all. It has its own section, and then for each row, I have its own, like it's called, well, sidearm role roster player, right? So I get the player's information from this class. So yeah, we're just getting an idea of what the HTMLs we're going to be dealing with look like, right? So let's now just get started with the Python code we have for it. I'm not gonna ask you guys to like have to redo this, but I think we'll share with you the code, but I think it's important for us to go over it and understand what it's doing exactly. So starting with the first method, and that's the beautiful soup and request. I tried this method initially with all the universities and found that some did not respond to this. I did not get data back. It's because some of them have some JavaScript JSON APIs that they get the data from. It's not stored in the page. And for those, we use the different method that I'll be showing you, which is Selenium. But for now, let's just get started with this one, the request and beautiful soup combination. And for starters, what you do here is that the first 3 lines, of course, import the libraries we'll be using. The first one is request. We talked about it. And then once you have beautiful soup imported, you can installed, you can have it imported here. And same thing with pandas. Then what we're doing here is creating a list for all the years that we'll be scraping the data for. This is how we talked before in the page that we said we're going to be looping through this list to go through all the years rosters. We're going to modify the URLs with the items of this list. And then I created dictionary variables that stores all the universities I'm interested in. So you see, I'm not sure if a lot of you are familiar with dictionaries. It's basically a different form of data structure in Python that allows you to store a key and the values, right? So in this case, the key is the university's website, and then the values are the URLs we'll be using for each university. And of course, you can see like immediately that the URLs look almost exactly the same, right? The university's athletics website /sports/football/roster. And then to go through the different years, all you would do is add / whatever year I'm looking the roster for. And once we do that, we're gonna start a loop here. What we're doing is that for each university or URL, I have in this dictionary, which is here, universities, this dictionary, for each item in it, so in each university, I want to first create an empty list. And in that list, it's called all players. I will store all that particular university's players, right, for all the years. And then I'll have another loop inside the first loop. And what that one will be doing is we'll be looping through the years. So you can already see what we're doing here. We're looking first at all the universities, and for each university, I'm looking at all the years, right? And well, for each year in the list years here, for each year in years, and this one is the one we created, the list that's called years. For each item in it, which is each year, if the year is 2023, which is the current year, I'm just going to use the base URL as it is, right? Which is this one. I'm not going to add anything to it. And if anything else, all the other years in the list, which was 2010 all the way to 2022, we're going to change the URL to, well, we're going to take the base URL as it is, and I'm going to add to it the slash and then the year that I'm looking at. And what will that do is we'll create, will basically give me URLs for all the years. Before I continue, I want to make sure that everyone's on board. Is it making sense to everyone, or anyone has any questions so far? Where can I find this file? I'll be sending you guys after this meeting a GitHub that has all the codes and all the data I'm sharing with you right now. So we did not share it with you yet, but we'll have that sent to you. Of course, no worries. Okay, any other questions? Awesome, I'll continue. So next thing we have is this comment I have added right here. You see under the year, this one I will highlight right now. You'll notice that some universities or even some sports within the university, they do not put the year after URL. Instead, they put a season. I'll show you an example of that. Actually, I think it's the men's basketball. They do that in UW-Madison. Men's basketball. So this is the uwbadgers.com/sports/men's basketball/roster. And this is for the current season, right? If I want to look at previous ones, look at this. They don't put year, they put a season instead. So if I want to go to 2020/21 season, this is what the link looks like. What the link has after roster is not just /2020, instead it has /2020-21. And they put the year for the season. They don't put the year itself, they put the entire season. So this is a quick adjustment we can make to the code to account for that when we have this particular formatting for the links. And the way we do that is that I'll add another variables, which is called year +1. I call it year +1. What it does is that takes the last two numbers or the last two digits in the year and add one to it. And then I'll compile both together to make the new URL. So in that way, the URL would be exactly what the formatting is. And then next thing is, well, when I get, we'll use request to get the URL content into the Python here. We're gonna load whatever content of that page into Python, and we're gonna parse it using Beautiful Soup. What's that doing is that this gets command here. What's doing is that it getting the content of the URL we're gonna put. So we created the URL, right? So I want to navigate to it, go to it in the internet, we do an HTTP request that gives us the content of the URL. And once we have that, basically what Beautiful Soup is doing is making it easier to deal with and making like parsing the HTML so we can extract the data from it. And then now once we have a more organized HTML file, now we can look for whatever class we were looking for, right? So in this particular case, I found that all those universities, and this was just luck, honestly, it was nothing else but luck, is that all those universities have the same formatting. For the schools I was doing, I had like about half of them had the same format, and the other half each had its own format. So I'm showing you the easy half that had all the same format, and I think you guys will encounter the same format a lot with the schools you'll be doing. And for that case, well, since they all had the same class name for the attributes I'm looking for, all I tell it is that, well, in this organized HTML file we call soup, find all attributes of class, this name here, which contains the player's information, right? And then in that content you found, you're going to find all those different variable names. Name is going to be the first one in that card, the player card. the position is going to be the second one, height, weight, and so on. And for all, I'm going to create this empty list here, or empty data frame for the players to store all this information for each individual player. What we're going to end up with is that inside this loop, I'm going to go through all the players for that. So now you see we have three loops inside each other. The first one is to loop through all the universities. The second is to loop through all the years rosters, and then the last one is to loop through all the players within that roster. And this is this last loop right here. And yeah, finally, once we have that, all this information we extracted is not going to make sense if we don't identify the year that we extracted it for. So I want to make sure that we add the year as a column at the end. We append every single one of those items we loop through, and we end up with this data frame called all players that contains, well, basically all the players for that particular university. And I created an automating way to save every individual university's file into a CSV here. We'll just basically, we keep the name dynamic. So because I'm looking through all the universities, I want to make sure the university's name is in the file. We have this variable here called university name because this is inside the loop. So it's going to include the university's name. And save that roster for that particular university in that particular sport. And this is all the first method. This is request and beautiful soup. And what that will end up giving you is, well, data that looks like this. Oh, let me start a new share. So let me open it here. This is my CSV file. I'm opening in Jupyter. You don't typically open in Jupyter, but I'll just show you. I have a column for the name, position, height, weight, academic year, hometown, high school, and year. And then I see the data for all the universities roster all throughout the years I'm looking for. You can see the year at the end here. And you see we got all the years we looped over. So this is it with the first methods. Once you click run in this, it typically, where is it? Here. Once you click run this, well, if you have only one university, you'll finish fairly quickly. Actually, let's run it once now to see what's going to generate, right? But I'm gonna only keep UW Madison, or UW Badgers football. I'm gonna give it a name because I have it already created, so I'll call it workshop. I hope it doesn't take too long. Let's run it. While it runs, actually, while this runs, we're gonna start looking at the other method to save time because we already have an hour in. So I want to make sure we cover the other method because I think you'll need it even like from outside this application. So we'll wait for this until it finishes running, and once it finishes, we're gonna print this data frame we stored the data in to see what we got. The second method is using Selenium, and what this will be doing is automating the WebDriver we have downloaded just before the presentation, right? So I have downloaded Chrome driver, and I stored it. Sorry, and I stored it in the same directory as this file I'm working on. You need to do that because, well, this file is going to access the either. If you don't want, you can just specify the directory it's at. So just for convenience, I kept it in the same directory. And I'll show you how this runs actually because, well, this one's fun to watch. The way this works is that, well, first import all the libraries you need. And of course, like keep in mind that a lot of these things, like when I started doing this project, a lot of these things I didn't know how to do. There's always ChatGPT to help you with explaining a lot of these concepts and even writing some of the code for you. A lot of this code, I didn't write it myself, a lot of it ChatGPT did. So make sure you make good use of it. It's not a school project. You can make use of these sources. You import all the needed library items that we're going to be using. You initiate the driver, which is basically, in this case, the browser. I'll try to share with you a screen to show you how it works after we go over the code. And then you list the same way we did about listing the years. We create the list of all the years so we can loop over. And you put the base URL. In this case, I'm looking at Ohio State. right? So let's go look at Ohio State roster first before we run this code. So this is the Ohio State roster. You might think it looks similar to what we just dealt with, but once we inspect elements in it, you'll realize that it has different namings, it has different formatting for the HTML. So using Beautiful Soup and then Git alone would not give us all the data we're looking for. Because first of all, what we want to do is that when I first open the page, it automatically takes me to this view, right? It's called, if you hover over it, you'll see the name of this view here. This is card view. And what you want to have is a table. So I need to be able to automate the select of on this page and selecting this particular button, right? So what I want to do is that, well, I want to inspect, I want to look for this element, find the name of it, and tell Python to go click it. So inspect. I click inspect here and I go to this button. It'll show me the name of it. There you go. Well, there I found the class for it has this name. So if I copied this class name and then through Selenium, I tell Python to, well, find this button and then click it, so it takes me to the table view of this roster. And this is what we'll be doing, is that we're going to automate this process of clicking this button and getting this table. And of course, once you get this table, we'll be extracting the data that's in it. And you can already see that, well, this is formatted a little bit different from what we saw. Some of them had like hometown/school in one column, and that's not even the biggest deal. You see like even messier formatting in its end. You'll find ways around it always, because like at the end, the concept or the structure is always the same, but just small formatting differences that could make the process a little bit, I say like lengthy, but it's generally not that difficult. So we go back. This is the second method we were looking at right now, the Selenium method. We looked at the link now for Ohio State. And again, we do the same thing. We initiate an all players data frame that's empty, that we can fill all the data for the players in it. And you'll notice first thing is that we don't have a loop for the universities in this case because, well, I'm only looking at an individual university, which is Ohio State. I'm not looping through a different university, so we already eliminated one loop. And the reason I did that is that because for all the other universities that were not in the first code, each had some kind of difference, so I could not loop through them all because I needed to customize the code for each. But in general, you can see it looks very similar, right? So I was starting with, well, for years, the second two loops were inside are kind of similar in the sense that, well, I'm saying the same thing with the roster. I'm only going to add the year at the end. And this has the secondary formatting that has the season and not the year. So I'm using this code instead of just adding the year to the roster link. And then I'm having the driver go to the URL, right? And once it's opened, when I run this, what's going to happen is that you open the web driver that we just installed. It's going to open like a Google Chrome opening. It's going to look exactly like Google Chrome, but it's going to be a different browser. Once it opens, it's going to navigate to this URL. You're going to see that, well, Ohio State roster is going to open, right? The first one, because, well, actually, there's going to start from 2010. And once it opens 2010 roster, it's going to first of all try to look for the button, because this is why I tell it first, right? Be like, okay, once you open the URL, first of all, wait 3 seconds for the page to load. And then once you wait for this 3 seconds, I want you to find if I have a table or not. This button is called viewed by table, the button we just found. And if you find the button, store it in this variable and then click it. Of course, button.click is a method that's used within the library we're selling, which is Selenium in this case. And if I cannot find the button, I told it to print for me, well, the button could not be found for that particular year. And that way I can investigate the cause of this error. And then after we do that, we wait another 3 seconds to load the other page that has a table. And once it does that, I tell it, well, find me now the CSS selector, which is in this case for the table, which has this name, right? When we inspect element and look for the table, we're going to find it has a CSS name. And if you cannot find the table, again, give us this error that tells us, well, timeout for this page, we cannot, for this particular year. And if it finds the button, clicks it, and then finds the table, then it continues after this, well, exception here. And then now it starts scraping. Now I tell it, well, identify the rows as the CSS selector for each individual row. So what it's doing is that finding all the elements that has this CSS selector, which is the one for the rows, and storing it in a variable called rows. And now I create an empty data frame for all players again. And now for each row in the variable that we just created called rows, I want you to find these attributes, right? I want to find the classes for all these, right? It has something called TDS, which each item stored in this row has a tag named TDS. I want you to go look for them and sort. It's different from the one we just looked at for BIOS. So this one instead, it has the rows have variables called TDSs, and then they're numbered from 0 to whatever number of variables I have in it. And so it doesn't have a particular name. For I tell it instead is like, I want you to find the first element in TDS, the second and the third and the fourth and so on, and assign each to the variables I have in the order that I see in the table. And does that for all, of course, all the rows that we have for that particular roster. And it adds them all to the data frame that we just created, all players. We append them the same way we did before with the beautiful soup method. And then finally, we store that year's players in this column called year data frame, and we add that eventually to all years players, which is the first one we defined above, right? Here, this one here, this first data frame. We add them all back to that one. And then, yeah, finally, I have stored this file in the CSV called Ohio Football Players CSV, and that's it. We close the driver. Make sure after you run any web driver, you make sure to quit it or put driver.quit so you can close it. It doesn't say running for the next command. So let's try what this looks like. I'm going to run it right now, and we're going to see what it looks like. If the first one finished, yeah, the first one finished actually. Let's look at the output of the first one. So we stored everything in this data frame called df, right? So let's see what df has. Well, I run again. df to CSV. Let me look at all players instead. It's empty. So we had an error this and did not go through all the players. Let's try to find why. In this case, I'll open the files that we have for the football players. Oh, it's right here. Actually, it worked. Yeah, it's sorted all in the CSV right here. Yeah, so we got. Oh, you cannot see my screen. Let me share the CSV. Actually, sorry. I opened it in the wrong window. Yeah, I'll show you the file after the presentation because I don't want to close this share right now. But in the meantime, we covered both methods. I want to show you one last thing before we close Python, and we're going to start looking at the files that we produced. Before I close this Python share or Jupyter Notebook share, I'm going to show you the last method, which the last thing we're going to talk about, which is the census API. As you mentioned, we're going to need some information about the players' hometowns because we're going to do some socioeconomic, demographic, and geographic analysis on where they come from. So we're gonna need certain information like about their hometowns, including things like the average household income that we saw in the analysis we showed last time. They include the average education level in those hometowns. So the way we do that is that, well, this is actually a much simpler way to do it. We look up on Google Census API key registration, right? The US Census provides a lot of free data, and that includes the data that we use for this project. But however, for you to access, you need to register for an API, and that's a very straightforward and easy process. You don't need anything for it. You just put your email and the purpose you're using it for, in this case, academic, and then they send it to you within a few hours, actually, even under. Census API registration request key here. You see census.gov, the government website, and it has key sign up. Once you click on it, it just asks you for organization name, in this case UW Madison, and your email address. and you have to read, of course, the terms of service and agree to them. And once you do so, they're gonna email you a key that you can use in this code here. Once they email you the key, you put it in this variable. I'm not going to use code, so you're gonna have this code. You just put the key that you receive from them, you put it here. And the way this works is that, well, you can read a lot about the census API and the information in it. There's tons of variables in it, and but we're only gonna be using a few of them. The ones we got are some demographic and some about the total population numbers, average household size, average age, and so on. And that's all coded here. These codes you see, B0, whatever, 1 plus E, whatever, those are the numbers of the variables that we are getting from the API. And they have thousands of them. And you can look up here census API documentation. It has information on all the variables you can access just using the API. They're gonna the same key that you're gonna get from this. You can use it to get thousands of variables, and it's all free. There's a long documentation on it, and there's tons of data you can get from it. In this case, we're only going to be getting this variables, but you can use this even after because I believe it has only expired after 2 years or something like that. I had it for a long time, so I don't remember last time I had to renew it. So it'll be very useful for you even in other projects, with school projects and so on. So I highly encourage you all to go and get an API, register for an API for it. Once you do so, it will be part of this URL. What this is doing here is that, well, same thing we did. So the data we get from APIs comes in something called JSON format. And again, we're going to use requests for that because it's basically getting it from the internet. And as we talked about, requests is basically asking internet pages. It gets to respond as JSON file, stores it in a variable called data. And then is this data, I'm going to break it into these columns that we're going to have the information for, which is, as you see here, for this variable, which was the percent of each particular like demographic background. So percent white was this code, percent black was this code, and so on. And we divide it by total population, so we can get a percentage eventually. And total population is also a variable that we get from the same API. So that's all I was going to show you with Jupyter. I'll move into a couple of more things before we end the wrap up. But for now, I want to stop and see if you guys have any questions about anything we went over so far. Anyone has any questions? Let's see, we got 2 chats. If no questions, I guess I'll have these codes all uploaded on a GitHub page that we'll be sharing the link with you for. And same as the census data, in case you guys don't want to go through the hassle of signing up for an API, something like that, because it's data limited, I'll just share it with you. And that way you don't even have to do this step. But in case you want to do it, I think it's useful for you guys, even in school, to have the API key. It's be very useful for you. I'll now move to I'll lose 5 minutes to go over the data, what's going to look like eventually. So I'll go over Spotfire, and this will be preparing for our next workshop, which is the processing part. So I think I'll need to start a new share for the Spotfire page. So in this page right here, don't worry about anything on the top here, all the section. I just want you to look at the table at the bottom here, this table right here of data. This is what our data will end up looking like in total. So I scraped so far all the Big Ten conference universities and end up with this many rows. It's 83,800. As you saw, each roster is about, for football, it has bigger roster, so that's about like 100 something. But for others, it's a much smaller number. And to get to that number, like how many universities we've done in how many years. So we get very huge data sets. And well, final data will look like has these columns. We're going to start with the name, position, sorry, height, weight, academic year, major, and hometown, and high school. And of course, we added the year. And then to identify each, we added a column for the sport, university, and gender. All the other things we added here, you're going to see a lot latitude and longitude. This will be a topic for our next workshop. How are we going to take a hometown and convert that to coordinates? How are we going to process all this data to make it ready for the visuals that we created that we see here? Something like this one and all the other ones we looked at. The preparation of data for these visuals will be a topic for our next workshop. But for now, is how we go from those websites that have the rosters to this table that has all the data that we try to get, which is the topic of today's workshop, web scraping. I'm sure maybe a lot of you have already started with the scraping part. A lot of you maybe found different ways to scrape data. I'm sharing with you 2 different ways I found, and there's tons of ways out there, but those worked just fine for me. And we ended up with the format we were looking after. If you guys need help with the process after we share the code with you, if you have any questions, feel free to email. But as of now, I think that will conclude our today's workshop. I'll open up for questions right now in last. I think we have like 10-15 minutes. So any questions? Awesome. If no questions, then I think we'll wrap up for today. Thank you all for coming, and hope to see you all next Wednesday for the next workshop. It will be about data processing and how we can convert this data into something useful. So thank you all, and have a wonderful night.
Thanks, everyone. And if you have any other questions too, feel free to just email us separately if you think of things as you jump off the Zoom. Oh, we do have one more in the chat.
Let me check. Can you explain the final goal for this project? Absolutely. So as we saw right now, let me actually reshare my screen for the dashboard. What we shared with you guys last time was this analysis we did on the players' backgrounds, right? You can see my screen now. We investigated this, the geographic distribution. We just even modeled something about their hometowns, where they come from, some things like household income, ethnic backgrounds. We did some forecasts as well. And the whole point of this is eventually you want to establish some sort of pipeline of where the athletes are coming from. And they'll be used by all, like ideally, of course, the ultimate goal is to have that used by sports team, whether it's within UW and even outside, to help them scouting and help them find basically establish this pipeline of athletes or where they come from and what factors make an athlete more likely to be a successful athlete in particular sports. So this is the final goal of the project. But for the meantime, we have a lot of exploration and data that we need to do before we get to that, and that includes the work we do in here, and then eventually the analysis we'll be looking after. I hope that answers your question. Yeah. Any other questions? Awesome. I guess we'll wrap up the session. I'll share with you guys the link for the GitHub page that has all the code. And if no more questions, I think everyone have a good night.
Thanks, everyone. Take care.